What's going on, everybody? Today what we're going to be doing is looking at 6.1c, expanding our number system. So if you remember in the beginning of the year when we talked about certain numbers, natural numbers, whole numbers, so on and so forth, we're going to go ahead and review that and actually add a few. So list the subset of numbers that we have learned so far. Now the very first things were the counting numbers, and the counting numbers are what's called natural numbers, okay? So we'll have natural numbers. And if you guys remember, these are the numbers like 1, 2, 3, 4, so on and so forth. And then if we talked about our caveman, if you remember, the guy was collecting out, counting rocks, and then he threw them at a dinosaur, and then he ran out. That introduced whole numbers. Whole numbers are everything before it, so like 1, 2, 3, 4, but it also includes 0. And then once we ran out of those, you had to go borrow some. So this introduced integers. Integers are basically everything before it, so like 0, 1, 2, 3, but it also includes its negative counterparts, such as -1, -2, -3. I want you to realize there's no fractions, no decimals here. So then what we need to do is we actually need to invent decimals and fractions. So this is called rational numbers. Sorry, I messed up writing that. Let me go ahead and rewrite it really quickly. So Jeez Louise, I can't spell right now. Let me go ahead and rewrite it really quickly. We got rational numbers. There we go. Now this is everything before it, like -1, 0, 1, as well as 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. But it also includes fractions. So like 2/3, negative fractions like -3/4, any decimal that ends, so like 0.7, and any decimal that repeats or goes on forever. Goes on forever repeating, so like 0.3 repeating. And it doesn't matter if these decimals are positive or negative. So are all numbers rational? So really quickly, a rational number is a number that just ends or goes on forever while repeating. I keep forgetting to say that, but it has to repeat. So no, because we know a very, 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 very famous number, and that number is pi. Pi goes on forever and never, ever, ever, ever repeats. Okay, so are all numbers rational? No, they can be what's called irrational. So you're going to learn a handful of these. One is the letter E. And if you ever take a square root of a non-perfect number, so if you ever see this symbol, this is not a division sign. This is saying what are two numbers that are exactly the same that multiply to 25? And I know that's 5. This is rational. But if you ever take a square root of a number that is not a perfect square, like there are no two numbers that never multiply to 3, this would give you a decimal like 1.7 something 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 that keeps going on forever and ever and ever, that never repeats. This is what's called irrational. So, can the square root of 2 be written as a fraction where the numerator and the denominator are integers? Explain why or why not. So really quickly, guys, if I have the square root of 2, one more time, can you think of two numbers that are exactly the same that multiply to 2? And you can't, okay? This is what would be called an irrational number. There are not two numbers that are exactly the same that multiply the square root of 2. So for example, numbers that are the same, if I said the square root of 4, what are two numbers that are exactly the same that multiply to 4? Well, that would be 2 times 2. So that would be this. What's the square root of 9? That would be 3. What's the square root of 36? This would be 6. The square root of 100? This would be 10. Because 10 times 10 is 100, 6 times 6 is 36. But there are no two numbers that are exactly the same that are going to multiply to 2. So rational and irrational numbers form a set of real numbers. Create a Venn diagram to show the relationship between the sets of numbers in the real number system. So guys, on a blank sheet of paper, what we're going to have is we're going to have this little thing, and I'm going to make a little Venn diagram of it illustrating this. So the first thing that what I want to do is go ahead and start with my basic of the basic numbers, and this is what we talked about already. This is my whole numbers. These are my natural numbers. And remember, this is 1, 2, 3. So then after that, we're going to expand, and then we're going to come up with the next one, which was invented the number 0. When we invented 0, that was 0, 1, 2, 3. And this is what creates the whole number. All right. So then let's go ahead and expand. We have integers. Integers is everything before it, like we already talked about. But integers include the negative. Okay. Let me go ahead and slide this over just really quickly. Sorry, let me go ahead and freeze this. Okay, so then the next one after this, we're going to look at a brand new set. This is going to be called rational numbers. So draw another square rectangle around this. And rational numbers are any numbers that came before it, so like -1, 0, 1, and any number that can be written as a decimal. So let's go ahead and do that together. So that would look something like -1, 0, 1. And I said any number that can be written as a fraction, like 2/3, 3/5, -5/4. Any number that's a decimal that ends, so like -0.5. And any decimal that goes on forever, so like 0.28 repeating. All of these numbers are rational numbers. We also came up with one thing that said, well, not all numbers are rational numbers. It's its own separate thing. Okay? These are what are called irrational numbers. These are irrational numbers. Oops. And these are numbers that cannot be written as a fraction. They're decimals that go on forever and do not repeat. Like we said, pi is the greatest one that we've seen forever. It's 3.14, so on and so forth. It goes on forever. And the square root of a non-perfect number. So for instance, if we looked at here, like the square root of 25 is 5, so that's a natural number. But the square root of 26, there are not two numbers that are exactly the same that multiply to 26. That would be an irrational. Square root of 2, square root of 3, square root of 5, so on and so forth. Those are all irrational numbers. But those numbers still exist in the real world, so we're going to call them a real number. So real numbers include all numbers that are irrational and rational. So really quickly, guys, when we're going to classify these, what you're going to do shortly, if I give you the number 0, you would say, is 0 natural? No. But is it a whole? Yes. Which means then it's everything after it. So it would be a whole number, an integer, a rational number, and a real number. So whatever the smallest group is, it's everything after that. So like we said, if it's a whole number, it's everything after that. If I gave you the number -7, is -7 natural? No. Is -7 whole? No. But is -7 a integer? Yes. And it would be an integer, a rational, and a real number, so on and so forth. If I gave you pi, you would say it's irrational and real. It's everything above it. Okay? So let's go ahead now and look at a few examples here. Here's the chart that was in your notebook. I like the one I made a little better, but if this one helps, you can also use the same thing. But if not, make sure you have the other one written down on a separate sheet of paper. So now let's go ahead and talk about this, guys. We have a square. And what I want you guys to realize is when you have a square, it's a bad square. When you have a square, the area is 25. It's saying what is the length times the width to get you 25? So that'd be like 5 times 5 is 25, okay? Are there any two numbers that are exactly the same that multiply to -49? And you might think, well, 7 and -7. And I'm like, well, wait a second. Those aren't exactly the same. No, you can't do that. So you're like, what if they're both negative? Well, a negative times a negative is a positive, and that wouldn't work either. So is it possible to take the square root of negative 49? Is it possible to figure out two numbers that are exactly the same that multiply to negative 49? Your answer is no. Okay? It's not a real number. You can't take the square root of a negative number. It's not impossible. It's not possible. So let's go and look at this now. It's saying figure out two numbers that are exactly the same that multiply to 4 and then multiply it by negative 1, that negative out in the front. This one's saying figure out two numbers that are exactly the same that multiply to negative 4. Well, like we just talked about, this is not possible. And the reason why is there are not two numbers that are exactly the same that multiply to a negative 4. On the other hand, if I look at the first example, this is just basically saying negative 1 times the square root of 4. So what are two numbers that multiply to positive 4? Well, that's just 2. And negative 1 times 2 is negative 2. Okay? So what we're going to do is we're going to put an x next to all these, and we're going to classify each of the following number by written an x under the set or sets in which it belongs. So it's basically saying what we're going to do is be collaborating on this one. It says work in your table, but obviously you're watching this by yourself, so we're going to just do it together right now. So 2/3. So as a reminder, I'm going to do this really quickly. This is like 1, 2, 3. A whole number is like 0, 1, 2, 3. Integers are like negative, all the numbers before it, but it includes the negative. So negative 1, 0, 1. Rational numbers is like negative 1, 0, 1, but then it also includes decimals and fractions. So decimals that end, repeat, or fractions. So like 2/3, like 0.7, or even like 0.7 repeating. Irrational numbers are like pi, square root of 2, numbers that go on forever. And as long as it's a real number, meaning not a square root of a negative number and not divided by 0, it is a real number, okay? So 2/3, it's not natural, it's not whole, it's not an integer, but it's rational and it's real. Something cannot be rational and irrational. 0.25, okay, well that's where the decimals start. Those are not natural numbers, not whole numbers, not integers, but they are rational numbers and real numbers. So we're going to see something a little different now. I got a negative 2. Well, let's see where negatives begin. So they don't begin with natural numbers or whole numbers. They begin with integers. So since it's an integer, it's everything after that. Okay, so it'd be rational numbers. And then, since it's rational, it can't be irrational, but it is real. 0 is a whole number, integer, rational, real. Now one more time, guys, we're going to go over this. We haven't really seen this yet. We're going to see them again. This is saying what are two numbers that are exactly the same that multiply to 36? Well, 6 times 6 is 36, so the square root of 36 is just 6. I'm trying to trick you here a little bit. So that is 6 is a natural number, a whole number, an integer, and a rational. And remember, since it's rational, it can't be irrational, but it is real. Now, I know the square root of 121. It's saying what are two numbers that are exactly the same multiplied to 121? That's 11. But can I figure out two numbers that are exactly the same that multiply to negative 121? So if you think about this, this is 11 times 11. Well, that's positive 121. If I make one negative, those are not the same. And if I make them both negative, negative times negative is a positive. So this, guys, is not possible. Okay? So this is not possible. Since it's not possible, it is none of these. It's not natural, whole, integer, rational. It's not even irrational, and it's not real either. So now let's look at this. This is a decimal that repeats. It goes on forever. So remember, this would be then a rational number and a real number. Okay, so now let's go ahead and look at this next one. This is saying 8 divided by nothing, 8 divided by 0. Remember with fractions, if you have a number, let's take a step back. If you have 0 divided by any number, your answer is 0. If you have a number divided by 0, that is undefined, which means it's not possible. So this would be none of them as well. We would leave it blank, okay? All right, now this one's also trying to trick you. I have negative 3 times pi. This is saying negative 3 times a number that goes on forever. Well, that's still, when I multiply, it's just going to be a negative number that goes on forever. So it's going to be irrational. But remember, guys, irrational numbers are still real. Same idea here. Can you think of two numbers that are exactly the same that multiply to 2? And you can. It's going to be like a number like 1.4 something 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 that goes on forever. If I take a number that goes on divided by 0, it's still an irrational number. Remember, irrational numbers go on forever and do not repeat, okay? But it is still real. All right, now this one's a little tricky because it looks like there's a pattern, but I need to figure out if it repeats. It's 2, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 2, 1, and while I can predict what the next one is, it'll probably have 5 2s, it does not repeat, it just gains another 2 each time. So this one is also irrational, but is real. Even though there's a pattern, remember it does not repeat. Now it says the side length of a square with an area of 8. So if I have an area of 8, and remember it's just length times width, can I think of two numbers, this is the key part, that are exactly the same that multiply to 8? So let's try 2 times 2 is 3, or excuse me, 2 times 2 is 4, and then 3 times 3 is 9. And 8 is right in between there, so I cannot think of a number that is exactly the same that multiplies to 8. So essentially then, it would be an irrational number and real number. And we're going to explore this more when we get back from spring break, okay? So show two different examples of non-real numbers, so not real. So remember, for it to be real, it needs to either be rational or irrational. So it needs to be a number that can be written as a fraction or a number that goes on forever. Non-real numbers are things like when you take the square root of a negative number. So one example would be the square root of like -4. There are no two numbers that are exactly the same that multiply to -4. And remember, 2 times -2 are not the same. That would not be an example that works. And then the other one is if I take the square root of, not square root, if I divide anything by 0. So like 5 over 0, -3 over 0, these are all examples of undefined. Okay, that's also undefined. So those are examples of non-real numbers. While these ones, if it's rational or irrational, these are real. Okay, so now what we're going to do is just kind of this little fun exercise where it says, I want you to tell you all the whole numbers from -2 to 4. If you remember, whole numbers are numbers that are not fractions or decimals, and the first one's 0. So like 0, 1, 2, 3, 4, so on and so forth. So there are no negative numbers that are whole numbers, so I'm going to skip those and put a dot on 0, 1, 2, 3, 4. Those are all my examples of whole numbers. Now, if it says real numbers are any numbers that can be written as a fraction or are irrational numbers. So that would be like any of those numbers. So if this is -3, this is +1. The real numbers would be anything in between it. So it wouldn't be those individual dots, it'd be any number on that line. So if I kept zooming in, those would all be answers, okay? All right, guys, for your homework, I want you to go ahead and work on 6.1c, expanding your number system. It shouldn't take you too long, and then we'll turn that in when you guys get back from spring break. I hope you guys have a great spring break. Yeah, we'll see you guys. Take care.